So for this question here, this is question 3 in WebAssign, but it corresponds to page. Let me get a pen going. Corresponds to page 121, number 1, exercise number 1, and it's the last 3 parts, D, E, and F. D, E, and F. And you have the answers, that worked out answer in the back of the textbook or in Canvas, in that course resources, Stevens Think Do with selected answers. So I pointed you to that. So make sure you check out those textbook exercises too for some more practice. Okay, you're going to see this stuff again. So some things what I notice about this is I see there's a quantitative variable. I see, sleep, hours of sleep is a quantitative variable. I'm trying to erase my writing here. Come on, I guess it's not going to let me. So I see a quantitative variable. I see, here, let me go to red ink. I see a standard population standard deviation. I see a margin of error. That's what they want it to be within. And then they tell me a 95% confidence interval. So how do I do this kind of thing? Well, if you go look on page 109, here, give me a minute. Yes, I've got the formula for figuring out the minimum sample size when I have a quantitative variable. It's all it's asking for is what value of z-score, what z-score do I need to make sure I encompass a wide enough width. And because this is a 95% interval, I'm going to go to that little mini table at the bottom of the normal curve table in Dr. Stevens' textbook, and I see for a 95% confidence interval, I'm going to z-score of 1.96. So that z alpha divided by 2 is the 1.96, and then the standard deviation. The standard deviation for this sampling distribution is, or population standard deviation is 1. And then I'm going to put that over what I want to be within is 0.2. That's the margin of error. I'm going to calculate those values, and then I'm going to square it, and then always round up, because if we round down, that's not big enough. So basically, this is going to be 1.96. I'm going to do this off screen. 1.96 divided by 0.2. Then I got 9.8, because multiplying by 1 doesn't change anything, right? So then I'm going to square it, and I got 96.04. So I got to round up and use 97. 96 won't be enough. Okay, so that's the minimum sample size I need to be have a 95% confidence interval and be within 0.2 of the true mean. Okay, so the next one is very similar, except now they just change in the margin of error. So instead of being 0.2, we're going to make it be 0.1. So I don't know if I can erase this. Let me try it. Yes, I can. Okay. So instead of 0.2, I'm going to go with 0.1, which is going to give me, let's see, can I erase this? No, that's locked. Oh, but I think I can delete it. There we go. So I'm just going to grab my calculator, go 0.1. I think that's 19.6, but it's early in the morning. 1.96 divided by 0.1 should be 19.6. It is. And so I'm going to take 19.6 and square it. So that cranks it up to 384.16. And again, we get to round up. So the sample size we need to be within 1/10 of an hour is going to be, and be 95% confident, is 385. Remember, we're going to round up. Here, the rounding rules, that's 1/6, so that even the rounding rules wouldn't work there. We always round up, so the round down won't be big enough. Then the last question here is 99% confident, same margin of error, right? See that? Same 99% confidence, different, and the same margin of error. So for a 99% confidence level, we need to use 2.576. I don't think they're going to let me change that. I don't think I can erase this. No. So what I'm going to do is I'm just going to be a little sloppy. Cross that out. I'm going to write in 2.575, and then everything else stays the same. So it'll be 2.575 divided by 0.1, which is the same as multiplying by 10, right? So it'll be 25.75. When I square that, I'm getting 664, because it's like 663.06, blah, blah, blah. So that's the sample size I need to be 99% confident and be within 0.1 hours of the true mean. Okay, so that's question 3. So I hope that helps. Go check out the one in the book. So for this pinworm problem, which is question number 3 in the week in chapter 7 web assigned, that corresponds to, let's see, question number 6 on page 121 or 122. And you don't have the answers to that. In fact, I think this is the quiz in the week 8, was it 122, number 6. So I believe this is the quiz on week 8. It's on that quiz, in that quiz. So what we're going to do here is, what do I notice? I see I've got a sample. I've got this is the number of people, and this is how many people had pinworms. So and I don't see anything about a standard deviation or mean or anything. So this is a proportion. So this is a section. Oh, let me look in the book. It's over here. This is section 7.3 in the textbook. Okay, so I won't go grab those formulas. You can go take a look at that. So what's the point estimate for this? Well, any point estimate is we don't know the population proportion of people with pinworms in this county. So we're going to use our sample. We're going to use our sample result as an estimate of what that population is. So in that case, we can do p hat. And you always take the number of successes, and the success in this case is somebody having pinworms, divided by the total. And so that's supposed to be 830. So 80 divided by 830 is 0.096. I'm not trying to, well, here I'm trying to keep web design happy, but right here is, I'm going to go 0.096, 4, I guess I'll go with. That's 4 decimal places. So that's my point estimate. Now they want us to, because this is a chapter on confidence intervals, we got to come up with they want us to come up with a confidence interval. So they want us to have a 90% confidence interval. So if we go look at that little mini table from Dr. Stevens' normal curve table, you see right 90% confidence interval, we want to go 1.645 standard deviations either side, right? So let's start getting this set up. So that's what I would write here would be 1.645. Now, what's the margin of error? So the margin of error is, I'll tell you what, let me write down let's see, what is it, 0.0964. I don't want to lose that number, but I want to delete this stuff down here. Okay. So we know the formula is going to be p hat plus or minus z star times the standard deviation for the sampling distribution, which will be our p hat times 1 minus p hat. This is the p and the q. All over the sample size of 830. And while I'm at it, let's erase z star and write in the 1.645. So this value here that we're going to calculate right here is the margin of error. It's going to go right here. That's what we're going to add and subtract from the point estimate from the p hat. So I am going to do this. I'm going to assume you can do this. I'm going to subtract 1 minus 0.0964 from 1. I'm going to multiply that by the 0.0964. I'm going to divide that by 830. And I'm going to take the square root of that. And when it's all said and done, I'm getting here, let me write this in green, I guess. That whole thing underneath the square root becomes 0.01024, blah, blah, blah. So now we're going to multiply that by the 1.645. And I'm getting a margin of error of 0.01685, blah, 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 blah. Okay? So then we're going to do to get the confidence interval, we're going to delete this here just a minute. Okay, so we'll do the p hat, the 0.0964 plus or minus our margin of error, 0.01685. And to get the lower bound, we'll do this part. We'll do this number minus that, and that'll go here. And then we'll do this number plus that, and that'll go here. So let's I guess I'll write that out. So when I crunch this, I'm getting let's see, 0.0795 as my lower bound to 0.1133 for my upper bound. So they say, are we confident that more than 6% of all U.S. this version of this question is saying, can I move that? I can. They're saying, are we confident that more than 6% of the U.S. adult pinworm? We do. We are, because 6% outside is below our lower estimate. Now, is this all adults? Yes. So because it's less than our confidence interval, we're pretty sure that it's the true proportion is higher than, at least based on the sample, is higher than 6%. And then in Sledge County, the proportion of adult pinworms found to be 15% or 0.05. And is this greater than the national average? It is, because that's way outside the upper bound. So something's happening in Sledge County. They need some public health services, it sounds like. Okay, so that's how you do this. Now we're back. This is problem number 6 in WebAssign for chapter 7, and this corresponds to, let's see, in the textbook, this corresponds to page 124, number 11, and you do have the answers to number 11. So there's another version look at it. So what do I notice about this? I notice that they're telling me the weights of Chinook salmon and the Columbia river are normally distributed. I got a sample size, so that's N. I see they want a 95. Oh, they tell me the sample mean is that, so that's X bar, and that's 4.8 is S because it's coming from the sample, and they want us to make a 95% confidence interval. So this is a quantitative variable, but I don't know the population standard deviation. But I have a sample size, and I've only got a sample size of 17. However, they're telling me the population of Chinook salmon are normally distributed. So we're good to go with a T interval. So how do we do that? So the point estimate is the sample mean. So they gave that to us, 22.2. Now they want us to construct the confidence interval. So I'm going to walk you through it by hand, and then I'm going to go take a picture of that Rossmann chance calculator. Or maybe you've seen enough of those and can use that problem. I mean, really, because it's a T distribution, the calculator is a lot easier. But it's the same math, so we'll walk you through it here. I've had some people telling me all I'm showing you how to do the calculator, not the by hand work. Well, you see enough. Dr. Stevens has plenty of a by hand work question, so that's why I'm pushing you towards the calculators. But we'll do another by hand. So to get a confidence interval for a sample mean or for a population mean, when I don't know the population standard deviation, it's the sample mean, the point estimate, plus or minus some t value that corresponds to the level of confidence. And then because it's got a normal distribution, we can say that it's going to be the sample standard deviation, sorry, we don't know the population standard deviation, is a good approximation to the standard, this will give us a good approximation to the sampling standard deviation for the sampling distribution using the sample standard deviation divided by the square root of the sample size. So let's do that S divided by square root of N, because they gave us all that. So S over the square root of N is 4.8 over the square root of 17, because we had 17 salmon. So 4.8 divided by the square root of 17, I'm getting 1.164. So that's this part. Now we need the critical value for t. Well, let's see. So I'm sure you've watched those videos. The way you get a t-score to use is you need the degrees of freedom. And the degrees of freedom is always n minus 1. If you haven't done this, you get a paper copy of this table, right? N minus 1 right there. So 17 minus 1 is 16 degrees of freedom. They want me to do a 95% confidence interval. So 16 degrees of freedom, 95% confidence interval. We're going to use a t-score of 2.120. So we're going to do 2.120 times the 1.164, and then plus or minus our sample mean of, what was it, 2.2 or 22.2. So we'll crunch this. We'll take 22.2 and subtract it. That'll give me that bound. And we'll take 22.2 and add it, add that product, and that'll be that bound. And then you look and compare it, just like that last question I just did. Is 18 bigger than well, it looks like, because I'm going to do 22 plus or minus a pretty small number, not much more than, well, let me go ahead and do these numbers just a minute. So is our lower bound, so I did these calculations, this product worked out to be the 2.4 number, and then so I subtracted that from the sample mean, got 19.7. I added to my sample mean, got 24.67. You see how we're basically kind of coming up with outlier fences? It's the same idea. So is 18, so a confidence, the mean weight of Chinook salmon in the Columbia River is greater than 18 pounds? We are, because our lower limit is above the 18 number. And then, so that answers that question. We could also say the acid is less than 25. And we could, because 25 is outside of this upper bound. So that's that. And why is it okay to use this technique when we have a sample size smaller than 30? That's because we have a normally distributed parent population. Okay, so I hope this helps answer the questions, or these questions you've had. If you want to look at some more, you can. If you want to learn how to use the calculators, let me know.